The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the nonprofit Hawaiian Volcano Education and Resilience Institute. Today is Thursday, September 5th, 2024. Kilauea has been a little quieter this week than some previous weeks, Dane. So we've had a little chance to catch our breath. How are you doing, man?
Doing pretty good, yeah. And no big storms on the horizon right now. And Yeah, kind of nice again to get back to somewhat normal.
Yeah, for sure. So we'll go through our data for Kilauea today, as usual. We'll continue our series on 1960s eruptions. Today we'll have the middle third, which is October 63, March 65, and December 65. Those are in an area of Nepal and Makaopuhi craters. We'll talk about those in our back half of our program today. But before we get going, anything to add, Dane?
Yeah, I mean, if anybody has any questions, there are going to be two parts. So volcano questions about current activity in the front, and then 1960 stuff at the back half. Go ahead and put your questions in chat, and we will see what we can do with them.
All right, thank you, Dane. I will start rearranging our screen here to get us ready for our summary. Hello, everyone. This is our Hawaiian Volcano summary for September 5th, 2024. The unrest on Kilauea's middle and upper east rift zones continues into September with moderately elevated earthquake rates, although overall the situation appears to have stabilized. We still have earthquakes in this upper east rift segment right in here, as well as this cluster by the Makaopuhi reservoir in the middle east rift that we believe is still filling with magma. This is the earthquake map over the past week. You can see the counts are still abundant there, with continued dispersed seismicity on the south flank and deeper earthquakes feeding from Pahala and underneath the root of Kilauea itself in these blues, and some settling events in purple as well here. If we look at the tilt meters across the volcano, we actually have a little bit of an online outage of the GPS station. The data is still coming in, but we cannot see it online yet. So we'll revert to tilt meters this week. So at the summit, we can see that these two signals of the Halemaumau area and the South Caldera area over the last week have very little net gain and tilt. They certainly have wiggled up and down, but very little change, and if any, maybe slightly deflating over the last week or so at the summit. If we go down to that Middle East rift zone bend by Maunaulu, where we had a recent intrusion, this is the escape road station. So this is near Maunaulu and those other areas that had intrusions in the last month. And we saw that big intrusion signal as this big drop in this green azimuth right here. And you can see that prior to that intrusionary adjustment right there, there is a slight decrease of this line, but we're decreasing from, call it 75 to 70 microradians on this scale right here. And I point out this rate because if we look since the intrusion here, there is certainly a initial phase here that has a little bit more rapid continuing movement. But what we can note is that in the past week, right through from here to here, we've dropped down from somewhere below 60, 65 microradians down to 80, 85 microradians. We've dropped 20 microradians in this station in a week, or tilted in a week, which suggests this is the area closest to the filling center of magma underground right now. And we are restricted to only the locations that have tilt meters right now. We go further down the rift zone to Puʻu'ōʻō, which is east of that inflation center. And that initial pulse that swept east across Makaopuhi crater about a month ago was registered on Puʻu'ōʻō a little less than a month ago. And since that about week-long adjustment, we've had fairly stable signal at Puʻu'ōʻō as well. Some little wiggles, but you can see the magnitude here is really not that great compared to the other graph we just saw. So that is the signals on Kilauea. As far as earthquake counts, they're still moderately elevated, but not nearly to the rates we saw during these accelerations in activity and intrusions as well. So moving to Mauna Loa very quickly, earthquake rates there are quite low, in fact. Looking at earthquakes per month over the last 5 years, you can see here that we're still in this recovery period following the 2022 eruption, fitting a regular pattern, expected pattern of Mauna Loa refilling following that eruption. And that's our volcanoes summary for this week. All right, so we'll move on to our observations. And for that, I will flash up our East Rift Zone webcams, which today are kind of hazy. There's some weather moving through the area. So this is looking north from Maunaulu. Pauahi crater is in the mist over here, Hi'aka behind it. You can see over here at Puʻu'ōʻō that there's some haze filling the area, some mist, and not a whole lot of action on the ground. It's getting dark out there as we are approaching equinox, or so Maunaulu looking east, a little bit more water over there as well. So not a whole lot to see on the surface, but it's interesting to see these views changing from week to week when we happen to look in at them. At the summit, it's wet as well. You can see the camera's got some water in a lens here a little earlier today, so not a lot to see on the surface. Underground, looking at earthquakes. Here are our last 2 weeks colored by depth. That means the blue ones are all deep, the red ones are all shallow. And this is fitting a regular pattern with a hotspot source causing this long-standing deep Pahala earthquake swarm. A bunch of scattered plots that are background activity settling of the island on the seafloor. And then looking closer into Kilauea, this is where all the action has been in the last 2 weeks, is right in here. And you can see there are a cluster of Upper East Rift, Middle East Rift at Makaopuhi, and South Flank events, as we previously described. So it's the standard familiar pattern we've seen for a few weeks now as far as the earthquakes. To look at the highlights for this past week, we'll come to our main USGS site, where we can sort our earthquakes by magnitude over the last 7 days. And here you can see we actually had a 3.5 as the largest event this week in that Upper East Rift cluster right in there. And this occurred yesterday at 6:50 in the morning, about a mile down below the surface. The next one beyond that was closer to last week, but a 3.0 in that same area, and 2.7, 2.7. So you see there are a few handful of larger events occurring, still ongoing in the area. So that's really the highlights for earthquakes. There's nothing really that unusual to point out here. So we'll move on to our monitoring segment. And I will start off with the USGS daily update issued this morning, 8:44 a.m. And the text is very similar to what we've seen in previous weeks. So the volcano is not erupting. Earthquake activity remains elevated. Changes can occur quickly, but there's no signs of imminent eruption. That's the same as we've heard for the last few weeks here. And they go on to provide earthquake counts, gas emission rates, but there's really nothing else worth highlighting here that's unusual and different. So for now, things are stable, but we can still see that the ground is moving, and I would expect some change will be coming at some point in the near or middle term future. So looking at our GPS data here, this is a 2-year GPS we're used to looking at. And without going into what all of this means, I'll just jump to the conclusion here and point out there's a big gap in the right side of all these graphs right through here. So we really can't see what's been happening over the last week on our GPS data. This is likely just a remnant of the transmission from the storm that came through with some winds. So every time that this has happened in the past, we've seen the data is restored once the USGS can restore that connection. And sometimes it's something in the software where it doesn't get uploaded to the website, so we can't see it online here, but it is still being collected. And we'll have to jump back to that analysis in the weeks to come. So as we pointed out, the tilt is what really is our indicator today. And we did note last week we had this extra signal from the Puʻu'ōʻō station coming in. And what it showed was right in the middle of the day. And so these date marks are noted right at midnight of each day. So right in here is about midday, and you can see that there seems to be a very distinct daily effect. So maybe it's a temperature effect or the sun hitting something, but every single day they're getting all this noise right here. And so you can see that after a few days, they actually cut it off, and perhaps they're recalibrating or repairing some elements of that installation there. So we'll wait for their word on that. Overall, though, you can see in the blue line, which says Uekahuna, we start off at about 0.5 microradians, and we're ending up just below 0 microradians. So we're actually a little bit more than half a microradian net loss over the week, with a lot larger variations between then and now, but just showing how overall it's fairly stable compared to what we've seen in the past. And to illustrate that, here's the whole last month. So the first 3 weeks of this month, you can see a clear inflationary trend. And this last week, you don't. And so that's the big change this past week. But that paired with what we see on the escape road station, which I'll scroll down here since we've seen some of these already. The magnitude that we see here is what really makes this the most likely candidate for where the magma is going. And it may be that much of the magma that may have been reaching a summit previously to cause inflation there may be diverted to this area now. And that's really hard to tell without our data streams that we're used to. We're kind of spoiled by being able to see INSAR and having our GPS stations all over the place. It's hard to really make any extrapolation with one data point in one location here. So, but that's what it is. And the important thing that we can tell is that it's not really reaching Puʻu'ōʻō area yet. And that's really our main concern as far as hazard to people still. So all clear still for now. Further down the wrist, even quieter. This is Jonica Station on one of those 1960 flows, only showing movement from earthquakes and otherwise very little ground tilt. It's essentially flatlined here. So that's our tilt and deformation for this week. And we can pair that with the earthquakes now to kind of tie them all together. Sometimes when we see these inflationary peaks and deflationary peaks, we'll see the earthquakes correspond to that trend, and it does not seem so obvious here. It seems a little bit more random. We did have a peak of about 200 earthquakes in a day last Friday, but since then it's been fairly random within that elevated moderate range. There is the one, if you look at the red line, there is the one big jump in energy release, which was that 3.5 earthquake. That's what this line is measuring, is how much energy is being released. So lots of small ones can occur, and it might not jump it that much, but one big one can jump it. So this is a good measure of how much energy is building up in the system as well. Looking at the depth versus time on the earthquakes, we see that these are coming in the shallow bands as usual. And there, for example, a small little gap with another one of these pulses of earthquakes coming through. And that's still the character of what we're seeing here. Pulses of activity coming in, building up pressure, and then potentially, if it builds enough pressure in one area, what we might look for is whether that magma migrates elsewhere, whether it's east into the East Rift. There have been cases in the past where it's gone west into the Kauai fault zone as well. So that also opens up that whole Southwest Rift, South Caldera, all of that's part of that same triangle. So there's still a lot of parts of the system active right now. We've seen the earthquake map for the last week, so I will move past that. And come to our last month of data here. So we've seen the tilt meters, the earthquakes really showing how we are elevated over the last month. When we zoom out a little bit, we can see all the circles are stacked one on top of the other. So there's certainly elevated activity, as you can see here, much more so than the background rate we see in the blues and a deep Pahala hotspot source. And let's see here, earthquake counts for the last month per day. Here's our most recent intrusionary pulse, and very quiet since then with this sawtooth pattern variation there. So over the last year, now earthquakes per week, we can see we've come down off of our last month's high. And in earthquakes per month, over the last 5 years, we can see that this last month did end up being lower than the previous of July, which, due to that 3-day earthquake swarm and intrusion, really set the record for the last 5 years. So still overall building, you can see this pressure building adjustments in the East Rift at the summit. That's all still ongoing. And that's still something we cannot see in our GPS. Once again, data missing from our summit and East Rift GPS. But on the East Rift, you can see this signal of that wave of inflation from west of Puʻu'ōʻō sweeping to the east and causing some variable movement between those stations. That's actually producing a signal now. But as we examined before, and maybe here I can come back to our GPS page just to point out the history of it. At the Middle East Rift by Puʻu'ōʻō here, and what we can see is that both of these stations on either end of that line are moving east and north and up in sync, essentially. Just at slightly different rates. They're kind of both going away from us, and one's going slightly faster, so that's causing that little bit of separation that you see in this plot. So that's our monitoring data from the ground. We have one more data set, which is our satellites, and today we'll turn to the Mounts project once again. This is a limited field of view. So here we are looking at the summit of Kīlauea, and we don't get that Upper East Rift or Middle East Rift in this automatically generated image. But what can we see? Maybe it's useful compared to the previous iteration, the last 2 weeks, which looked like this. At that point in time, we were seeing inflation centered in the South Caldera, extending from the summit all the way into the Kauai, and that followed adjustments we saw in the Middle East Rift prior to that. So stepping back to what we see now, you don't see that inflation center so prominent in here. You do see some of these rainbow bands right within a lava lake itself that's been hardened and crusted over for over a year now. Maybe not quite over a year. Yeah, maybe this month it'll be over a year. And it looks like from the pattern of these rainbow fringes here that there is deflation happening in this area. So maybe very locally to the lava lake, it seems to be deflating a little bit, perhaps to feed magma coming down to the Middle East Rift somewhere. In the past, we were able to see through this vegetation, which is what's causing the speckled colors in this part of the image here. Sometimes we'll see little hints of rainbow bands appearing in this area, but they're really hard to pick out if they're not very strong. So there's a hint that there may be something happening here corresponding to our escape road tiltmeter, but not very clear, and we'll have to await further releases from the USGS and their satellite partners. So that is our monitoring for today, and we'll wrap up Kilauea with a quick touch-in on our volcanic hazards, which are still the gases. Right now, gases are the largest hazard on a volcano to people. We use the VMAP project, Vog Measurement and Prediction, out of University of Hawaii at Manoa, to share their forecast of emissions combined with current weather, suggesting that from volcano emissions at these fairly low rates, you still get effects west towards Pahala and Ocean View, and a little bit shifting into the Saddle region as well, likely due to some Kona winds still lingering around. So that's the forecast for the next couple days. While currently in a national park, everything is in the green and has been so over the last 24 hours. Still, if you're a sensitive individual nearby, whether you're a resident or visitor, then take your usual precautions or follow the park's advice. So that's our hazards for today, and we'll do Mauna Loa, where there's not a whole lot happening as well. I will point out here, this is the webcam image from a little earlier today from Mauna Kea looking at Mauna Loa. Look at all those clouds in the saddle. The clouds are coming up the flank of Mauna Loa. Kilauea is on the backside of here, so that's all those clouds are what's covering all the webcams on our side of the island here. And I'm showing you this one because if I scroll up here, I will point out that it's been a little while since some of these other webcams have updated, and this corresponds also to our data updates not reaching the websites, right? So it's not just the GPS, also the webcams are showing some interruption of the feeds here. but everything is still pretty quiet on the mountain. It is the first week of the month, during which the USGS issues their monthly update for Mauna Loa, for which everything is normal. The seismicity is low. Everything is within the expected pattern post-eruption for the volcano. Just
Take your time there. Yeah, so Mauna Loa kind of doing its thing, huh? Relatively low activity, kind of rebuilding after 2022, that eruption. Not a lot of change. How you doing, Phil?
Yeah, thank you. I think I swallowed a frog there.
Happens.
So yeah, we'll wrap up Mauna Loa and I'll take my break here. But tilt's been pretty flat, apart from earthquakes, maybe some weather influence as we saw right around that same time. Earthquakes have been all in a shallow range, not a whole lot of deep activity, a couple of small things barely worth noting. And earthquake rates for the last week, many days with no earthquakes at all. Looking at the last year, many weeks with less than 5 earthquakes for all week, which is why we can summarize this pattern with the last 5 years showing very few earthquakes per month here on Mauna Loa. So that is the data on Mauna Loa to share with you guys. There's one final thing, which is a new USGS data release, and this is something that we'll pass to Dane to share about, but there's been a new release here from the USGS, so I'm going to pause here again, Dane, pass it to you.
Yeah, so about a month ago, I think it was now, we did an update that included looking back a little bit at Mauna Loa. Maybe it was a little longer than that. Anyways, one of the challenges we found was the maps weren't still online. And this goes back to all the way to 2018 and the data releases that USGS was doing. Until recently, they didn't have the authorization from Department of Interior to be able to share their own maps, their own layers of the maps, right? The GIS layers. So now they actually have that. And one of the requests I've put out there for years is for them to share the most accessible formats for people, which in my mind is something called a KMZ or a KML file. And these run on Google Earth. So Google Earth Pro is kind of the Mr. Potato Head of the GIS world, but for what it does it for free, and it has a very low bar of entry. So it basically means that anybody can now take that data set, import it onto their map, and import other layers onto it. So really excited to see that. Long time in waiting. For us, it's always been a struggle, and it's changed with every eruption. So now I'm hoping that finally with this approval, with them being able to release their own layers, everything's going to start to be more standardized and be more accessible to everybody. So really excited about that. Yeah, 6 years I've been asking for that. So yeah, cool.
Yeah, awesome.
Thank you. Yes, yeah.
So yeah, that is Mauna Loa, and we will just touch base on Volcano Watch before we take our break here midway. And to start this week's Volcano Watch, well, let's make sure. I think I missed my tags here. I should have put up Mauna Loa, which they're honorary, and Volcano Watch. Here it comes. All right. So this week's article is about photography and all the webcams that have been deployed and upgraded on a volcano. So without going through every single one, we've been keeping track. There's new webcams on a southwest rift on Mauna Loa, looking back towards Kīlauea. We've seen them on Mauna Loa's we did this already. On Kilauea Summit, B2 webcam, for example, they upgraded the pan tilt zoom K2 camera. So the MITD over in a southwest rift. They have MDL. They have MSP. These are on Mauna Loa. and M2. So lots of webcams being put out, and a lot of this coming from their funding with the Disaster Relief Act of 2019, their additional supplemental appropriations that came out of that. So great to see that, because as we've seen, it's challenging to be able to see these eruptions, especially if they're in remote areas. So the more cameras out and the denser the network, the better. And even still, there'll be times where we can't actually see things, right? Seeing eruptions really has always been a privilege. Historically, it's not always something you're guaranteed to see every time. So we do feel lucky that quite a few have been visible for quite a while. But when we review this area of the 1960s, you'll see quite the difference when there's a lot of eruptions were completely undocumented because people just could not get there. They could not see it. It was too cloudy, and then it was over. And that was the end of that. So that's still a challenge, the nature of eruptions, remote locations, accessibility, all of that. But we have a much better chance now with all these webcams. And so that's pretty cool to see that. And as I don't know if I've said this in a while since we've been streaming, but when I first came to Hawaii and to the USGS, and I was a volunteer, what we used to do is hike out 6 miles to try to look for a pixel of glow at one moment in time to see if the thing still had lava in it. Right? And I remember, in fact, in our internal reports, Don Swanson would drive up from Hilo, stop at the Glenwood store every day, right around 4 in the morning, 4:15 in the morning, and look at Puʻu'ōʻō and see if he could see it glowing. And that went in a report every single day, whether we could see it glowing at 4 a.m. from Hirano store. And so what a privilege we have now to have the webcam on there 24/7, catching everything, actually live video when we want it to be. So it's come a long ways in the last 20, 30 years. So that's the first Volcano Watch to mention. There was one from last week, which was released late, and that one introduces the island of Hawaii Interagency Operations Plan for Volcanic Eruptions. So what this really is putting down on paper the relationships that already exist, the process of information flow that already exists, so they can build upon it and improve and grow from there. So this is the first time that this has been done. And in this first version, they only included 3 entities collaborating to produce the plan. One is Hawaii County Civil Defense Agency, 2 is Hawaiiʻi Volcanoes National Park, and 3 is USGS-HVO. Right, those 3 agencies are the ones that are jointly putting together this plan. And you can see their graphic here where they're actually noting the latest eruption of each volcano and the threat that each one produces according to the USGS assessment, which is a national assessment. And the assessment both includes the probability of an eruption and the exposure of communities in the area to those kind of things. Right? So you can see that on this map, Kilauea and Mauna Loa are both very high threat, as well as Hawaii is high threat. Right? Mauna Kea itself may surprise some people to learn that volcano is just dormant but not extinct. Last eruption 4,500 years ago. To a geologist, if it's within 10,000 years, it is still not extinct. So halfway there, maybe not so energetic these days, but still alive and potentially will erupt again. So it poses a moderate threat at Mauna Kea. And those are our 4, right? We're not actually including Loihi, Kamaehua, Kanaloa underwater. We're not including Kohala. So these are the main 4 included in USGS threat assessment. So I won't go through like that plan in detail. I can flash it for you guys here. It is, what does it say here? 39 pages long. It lays out each of the agencies' jurisdictions, roles, responsibilities, how they interact with each other, all of that, how they coordinate their resources, including aviation, and how that works with temporary flight restrictions, for example. And so one of the clear things that they need to do is involve the FAA and other agencies in future iterations of this plan so they can actually make improvements and hammer things out. And acknowledge that there are many other agencies here that have a role in response that they would like to include in the future, but were not included this time. Department of Defense, HIEMA, Civil Air Patrol, National Guard, FAA, National Weather Service. I won't read all of them for the sake of our interpreters here, but you see there's a giant list of organizations here that certainly could be part of this planning process, including groups like our own, non-government organizations like our nonprofit. So great to see that documented. And that is the Volcano Watch segment for this week. And I will now flash up our community corner, and I'm going to pass it to Lou. So back in a bit.
All right. Thank you, Phil. We'll go ahead and get Lou in here. Hey, and howdy, Lou. How you doing?
Hey, how's it going?
So what's going on?
Well, I'm going to start us off with our community corner. Let me get this up on the stage here. There we go. So a lot has been happening at the park, we know, for the last several months with all the construction that's going on. And recently we just did the last live stream in the auditorium, the visitor center that is now closed. I'm going to go through a few things and show you just what's been going on up there with some maps. Nothing too much. If you need to know what's going on or you're headed up there, I recommend checking the national park, their website, for anything that's current. Okay. You can see from the list that I have right here, these are dates going all the way back to January 31st. So this is the Waikahuna parking lot area. We already know that they closed this down. The building's been demolished already, and a lot happening up there. Crater Rim Drive. As you pull into the entrance, there's construction happening at different times. Sometimes there's machines crossing the road. There's trucks. Just be aware as you go up there. Here's the visitor center parking area. This area is going to have a lot of activity going on over the next 2 years. Know that it is closed, and that pulling in there and around there, there's going to be activity. The Tree Molds Road closure, that's when you pass the main entrance heading towards Kau. It's going to be another turn just past there. That is to pedestrian and bicycle area only. This is the entranceway. The last time I was in the park, this was open, but they're still doing construction through this area. Know that during the daytime, the parking or the drive into the area, the front gate is 2 lanes, and sometimes it's 1, and sometimes there's buses. There's a cruise ship in the bay. Tours are going on. Plan accordingly. Know that you may sit there for 5 minutes. Maybe more. So pay attention up top. Here's some marks that I put on here. This is the last part of it. The restrooms, the main restrooms up at Waikahuna are closed. They do have our favorite porta potties out there, so use cautiously. KMC has some activity happening out in front of it on the main road. That's going to be 1 lane at times. Like I said, they're constantly doing things, and weather changes, construction changes. So what happens today might not be happening tomorrow. Check the website for current activity. And this weekend down in Hilo is the 25th Queen Liliuokalani Festival downtown Hilo. It is going to be busy. Mass hula, there's a flower drop. This always brings a lot of people in. There's overflow parking over at the Fukchin. Is that right, Dane?
Yeah.
The auditorium, right? There's a overflow parking over there. There'll be a shuttle. If you're going to go early and know that you may have to walk a little bit. We've been up and down on weather, so it's hot, it's cool, it's daytime. Bring water. There'll be water. There'll be all kinds of food and vendors all over the place, but just bring water with you and enjoy yourself. Wait for the flower drop. That's supposed to be pretty amazing. Are we still going, Dane? Are we on the books?
I think so. Yeah.
All right. If you're there, you see Dane and I, grab us and say hello. That's us there. And I think that will wrap us up for what's happening around our part of the world here. Yep. Oh, and as a friendly reminder, this is our webpage. If you'd like to donate to us, head over to hveri.org/donate. We'll get more into that later. All right. What do you got for us, Dane?
Good. Yeah, I did want to, take the opportunity to thank everybody for tuning in today. We rely on viewers like you with the likes and subscriptions, the shares. All that really does help on the back end with the algorithms and everything. So we appreciate everybody that tunes in these days where it's blue skies, where we don't have an active eruption. We know a lot of people show up when the lava's moving, but it's the times when it's not that you learn about the details that helps you prepare for when the lava's moving on the surface and what to expect, what's possible, what's outside the realm of possibility, things like that. So we try and provide that information here in a non-sensationalized, realistic format because we've gone through it and seen what the lava can do when it's moving on the surface in neighborhoods. So that's what's led to this work and continues to help guide us. So yeah, we also want to thank the Puna Strong and Kilauea Recovery Grants through the County of Hawaii and the Hawaii Community Foundation, HCF, for their continued support to help not only this program, but our digital resilience, as well as now our youth development our new project that we're working on. So thanks to everybody, and just wanted to thank you for being here. I think with that, we can
go ahead and roll those credits. And just to reiterate what Dane said, we are a 501c3 nonprofit organization, and you can donate to us a super chat here on YouTube or over at hveri.org/donate. Your generosity helps us keep going. It's our programs that are important to the community and keeps us on our toes around here. So your support would be much appreciated.
All right. Yeah.
I do have one other thing. If you have, guys, we did get our latest newsletter out that did go live. So I did pin it. So if you haven't received our newsletter, if you're not subscribed, go ahead and click up top in the chat. It's pinned up there. Check out our latest newsletter of what's happening, what we're doing for the month of September.
All right. Thank you, Luke.
You're welcome.
All right. And we will get Phil back in here. All right. There we go. All right. So questions. We do have a couple questions for you, Phil. If you are ready, we'll go through those.
Shoots.
All right. So first one is Buster Brown asked, do we know why the GPS data hasn't been updating? Is it just a hardware fault at HVO on the network, or is it something more serious?
Yeah, that's a good question, Buster. We don't know is the short answer, but we have seen this before, and it happens after every major storm like this. And I think the easiest thing to imagine is that the wind just blows the radio antenna out of alignment. I mean, these things are shooting sometimes 20, 30 miles across the island between one site and another. The wind blows it and it shifts by 5 degrees. That's that. It's not going to send the data anymore. So we'll be collecting locally, and they might have to just make time to go to the site and then put it back. Like, that's one possibility, right? Sometimes you have leaks and water gets into the system. You have some kind of electrical fault, something like that. There could be a hardware fault potentially localized to one instrument, right? When you see one instrument acting up, that's usually what you suspect. But when we see every single instrument having the exact same outage, then it's likely something with either the transmission into the building or the software in the building itself that got somehow interrupted and needs to be restarted, something like that. So we don't know the answer, Buster, but those are some ideas of what it could possibly be. And never in the past when we've had this happen has it been a total network failure.
Right. And it does seem like, would you think their network would be down too with this? Because we've seen before how the internal network's up, but the external one is down that we get access to? Or do you think everything was down?
It could be. It could be, yeah. Without having access to see their internet data, then who knows, right?
All right. So next question is from Nicholas. This one was a two-part question. I already did part one in the chat, so we'll try and focus on part two if that's all right. That question is, has Mauna Loa entered a new phase of dormancy?
I don't know that. Yeah, I mean, in some ways, yeah, you could define it that way. But this phase is the expected phase that follows an eruption, and it's the phase that we call the recharge phase. So, yeah, technically during recharge, it is dormant. It's not erupting, but it's it's the expected recharge phase. And the important thing to note is that we don't know what Mauna Loa is going to do next, right? We have seen patterns of Mauna Loa in the past where she's erupted almost every year, where we'd see a summit eruption, and within a year, we'd see a flank eruption. And we're not quite sure that we're back in that pattern because we've only had the first eruption in 2022 after, what was it, 38 years? What was it? I forget the math now, but yeah, something like that.
Yeah, something like that. Anyways, yeah. All right. Next one is also from Buster, who asks, is it possible that the Summit Reservoir has reached its upper threshold for capacity and is using the East Rift Zone to relieve pressure?
Yeah, I mean that's basically what's happening, Buster. But with the twist that the capacity of the summit is constantly changing and increasing because the boundaries of that area are moving. Those blocks of land, like the south flank, moves away, and that creates space, and then that increases the capacity. So it's that dynamic between the south flank and other areas of the volcano moving away to create room underground, and the flow into the volcano, and whether those compare, one being more than the other, whether they're equal or what, or vice versa. So it's that dynamic that really has the impact there. But for now, because we are seeing earthquakes on the Middle East Rift, then the pressure is able to move that way, right? So if you think of it as like a system that has maybe some areas are stronger, some are weaker, right now the weakest spot is towards the East Rift. And as it fills and pressurizes and is able to build more pressure, then that may not be the weakest spot any longer. It may shift back to the summit, and the summit may be what erupts next. That's impossible to tell because we can't keep track of every single block underground and how the pressure is affecting it as the magma is moving through there. We're just trying to guess in some ways, like where is the magma actually at is hard enough without trying to figure out what are all the dominoes that are falling because of it. So we try to focus on the big pieces, like what's the whole south flank doing, especially in parts here and there. And that's how we try to break it down as far as looking at the data and different sites and explaining it with maps and different charts and all that, is to try to, as much as we can, break out the little components of it. But the big picture, you're right on it. That's it. For now, the summit is happy, right, pressure-wise, and the weak spots down towards the rift, and that's where it's sending the magma and pressure.
All right, we got a couple questions from Facebook. Go ahead and do those. First one is from Dave Bennell, who asks, over a much longer time frame, you guys monitor for so long, do you see patterns are similar, or the earthquake pattern somewhat different? Talking about the deformation 2020 and between 2018 and 2022, or 2020, sorry.
Between 2018 and 2020?
Yeah, so including 2020, I believe. Or including 2018. Or 2018.
That chunk of time. We're just picking a random period of time out of the blue. It seems like it's not really relating to what we're talking about here. So I'm not sure how to answer that.
Okay.
We do see patterns that are similar again and again over the course of the volcano, but I don't think that what we're seeing now is relates to 2018 and 2020.
Okay.
It relates more to what we see in the 1960s, which is why we're bringing that up as our special presentation this week. I suppose let me try to let me pull on this thread a little bit. Following the 2018 collapse, there was some inflation on a rift zone, but it was not thought to have come from through the summit and down the upper pathways. It's thought to have come from the deep rift areas and come so essentially it's like getting up off of a foam mattress or something, right? You relieve that pressure above, and then what's below can kind of rise back up. So it's thought that there was inflation for maybe a year and a half following that. That kind of pressure, when we saw the first eruption in 2020, that the USGS actually said that there appeared to be backflow from the rift back up towards the summit to relieve pressure that way, right? That's like the opposite of what we're seeing right now. But it also was sourced from below and going the other way rather than being sourced from above and trying to come back down. So it's a similar pathways, but it's all reversed because the volcano has repaired itself. And this is actually part of what's happening now, is it's repairing itself from the 2018 collapse still, right? Because prior to 2018, we had lava coming through the summit, going all the way to Puʻu'ōʻō for those 35 years. And yeah, that's that change in 2018. And now we're trying to reestablish a path back towards that Puʻu'ōʻō area. So hopefully I got to what you were getting at there.
Yeah, I think you got it. Next one is from Yvonne, and it's kind of a lot, so I'm going to try my best here to consolidate it down. But she went back out to Kane Nui Ohamo and saying that the cracks out there and some of the lava trees have moved between up to 100 and 140 degrees Fahrenheit, and that there's more trees that are hot. And some of the areas show evidence of past venting with altered rocks where the heat has cooked the rocks. The new areas have not shown it yet. There also was the 1962 eruption nearby, plus the magma storage area is nearby underneath. Could this be an old hot area that just got reactivated again because of the recent magma intrusions? Or could it be totally unrelated and it just created a new hotspot due to the recent magma intrusions? So yeah, new heat essentially.
I think to kind of cut to the chase of what Yvonne's saying there, I think if you do see cracks widening and areas steaming that weren't before, that's due to new magma, basically, rather than something old moving around. It is possible you can say, okay, maybe there was some groundwater or some crack or an earthquake might have redistributed things. But in this case, we know we had intrusions. We know there's magma there. We see the inflation wave sweeping across the landscape. So I think I would heavily lean towards it's the new magma causing those cracks and causing all those dead trees, right? And what we're going to see in this area of the 60s, mostly what you're doing is injecting the Middle East Rift over and over and over again. And once in a while, it actually leaks out through the cracks and causes an eruption. But most of the volume of all this work happening in the 60s, and possibly now as well, is actually trying to feed underground into the rift and reestablish that pathway by injecting and injecting and injecting and injecting. And maybe 1/10 of that leaks out, like we saw in the Southwest Rift eruption that just happened in the middle of June or in the beginning of June. So, yeah, interesting times.
Right. I think that gets us through our questions and answers for segment 1, and we can go ahead and into our special for today.
All right, and yeah, hopefully we'll get to dig at Dave's question a little more and maybe show some parallels here of what might actually be the patterns that it's hard to tell, right? Which era and what phase of the volcano actually applies right now, but this is an era that seems more relevant than ever. Probably because most of our lives, the lava was coming out of Puʻu'ōʻō from one spot, steady state for decades and decades and decades. And so this is different. And so were the 60s. So let's jump into it then and pull up our activity table from Kilauea. And if you haven't joined us in the recent weeks, we've been going through these 9 eruptions that occur in the 1960s on the Middle East Rift. And our bookends are the 1960 eruption that happened in Kapoho in the Lower East Rift. There are 3 summit eruptions that follow that in early 1961. And then here is our number 1, number 2, number 3. We've done those in our past updates. Today we'll do number 4, number 5, and number 6. Following this trio that we'll cover today, there's actually a 9-month interval of summit eruption with a lava lake active for 9 months. And then we go back to the Middle East Rift. We'll conclude this likely next week with, we actually did number 7 as an anniversary last month. And we'll finish off number 8 and number 9 before the other bookend, which is the Maunaulu eruption, which goes really from 1969 through 1974, all of that in there. So that's just the overall big picture in case you have not seen it before. One thing to remind you of is that in this era, this is the layout of the national park. And I'll highlight to you the roads, especially the Chain of Craters Road exists down here. The Napali Road exists already all through here. But if you note, where does the Chain of Craters Road actually reach? It goes by Hiaka, Pauahi, Aloi, Alai. Notice Maunaulu does not exist yet in between here. Past Alai, it gets to Makaopuhi crater, and that's where there's a turnaround and overlook. So this is as far as they can easily get in the 1960s to see an eruption. They are limited with their aerial resources, right? They do ask Civil Defense and Air Patrol and the Navy for help in this era, but they have to wait on them for when they can provide them the data. So what we'll see is that many of these eruptions in this phase are going to occur further east from here, and that makes it so they really don't know what's going on for a lot of the time until after the fact. And one exception is that middle eruption, which actually does occur in Makaopuhi. So they actually can drive to it over and over and over again. And that is the highlight of this era for the geologists, since they could measure things they could never measure before. So that's the situation at the time. And to review like the sequence of where these things were occurring, this is the eruption number 1, which was the one that immediately followed the Kapuho eruption and summit eruptions. And on here, this was September of 61. And so September 22nd, 23rd, and 24th between the Pau craters. And this came all the way down to close to Heiheihulu over here. So technically across into the lower east rift, barely at the bottom end over here, not too far from Pahoa. But that was just showing how open the rift zone was immediately following the 60 eruption. And that was to here. And what we see over time is the next eruption that comes up in 1962 in December does not go nearly as far down a rift. It's restricted to this area of Makaopuhi crater over to Aloi Alai craters all through here, right? And the Pau, the western edge is right here, so the previous one. And the one that follows in 63 was fully inside Alai crater. So if I pull back to this previous map, it was all inside of here. And within that, you had a lava lake filling the bottom of the crater and some fissures across the top and down a wall. And so this may ring a bell if you've been with us for these previous eruptions. And to tie it together and show what comes next, I will switch here to our Google Earth and point out here is that 61 eruption. There's bits of it all the way down here, some bits in here, and some bits in here. I'm going to add 62 December. That comes in right in here. And these purples right in there. There's Makaopuhi crater, Maunaulu today, but old Alai crater, you can kind of see the trace of it here. This used to be Alai crater. It's completely filled with lava now. Zoom it out to come to this side. And underneath that dot right there is Aloi crater. And you can see it a little bit today too. Let me turn it off. And there's a trace of old Aloi crater buried under Maunaulu lava flows, but see it on the map there. There's a second one, and a third one in Alai crater right in there. Okay, so let's continue the menu here, and I'm going to add 63 October. So this is the first one we'll talk about, will be this one in blue. It begins in the Pau crater and goes all the way east to this area of what's called Kilauea crater, right around here. Right, so there it is. We'll get into that in more detail. The one that follows, well, so first let me say this is October 63. This was a third eruption within a year. Right? We'd had December 62, August 63, October 63, third in a year that follows those previous eruptions and gets as far as Kilauea. Then after about a year and a half or so, we have the 65 eruption, which is in a very similar location, almost covers all of the 63 flow, with added bonus of it puts out an extra flow in Makaopuhi crater right there. So I'll flash it off and on. And it's this that the scientists are able to then document because they can drive right up to it into that area right there. And then the very last one in December of this sequence I'll talk about today, let's pop it up here. It's just uprift right over here. In a very similar area is a 62 eruption, actually. So let me pull off the other ones. Let's take off this one, that one, there and there. And just let you compare how close the 65 December and 62 December eruptions actually were. They're almost covering each other up right there. So that's what we're going to talk about today. We can come back to the map if we need to. But to kind of put it all together, there is how far we've gotten in this decade of the 60s of eruptions and why it looks relevant, right? So, all right, we'll come to this paper that describes the 63 eruption in October by Jim Moore and Bob Koyanagi. This is professional paper 614C. And I will scroll through and just try to highlight some important parts, but there is a lot of detail, and this is the only documentation we have here. So what we can say is that that eruption occurred over an 8-mile section. There was 9 million cubic yards of lava. And for reference, I think our two most recent summit eruptions were maybe 15, 16-ish. So about what we've been seeing in our summit eruptions, about that amount of lava. But they actually had more than 30 fissures, and lava covered 1.3 square miles of forest. And one thing that's notable is in this era, there's a lot of forest and not many lava flows on the East Rift. So much of the East Rift is getting bulldozed, repaved, cleared by these flows in this era of the 60s. Prior to this, this is all vegetated and doesn't look anything like we're used to seeing it like today in the 21st century. Most of these have the same pattern where they see, well, so in this case, a few hours before the actual outbreak, they saw deflation at the summit, and they saw tremor and earthquakes both at the summit and by Nepal. So that's the key of it there. I will not read any more from that section, but rather let me come down to the map and point out the earthquakes that they're mapping out occurring in these areas. So here's Nepal crater. There are the earthquakes in that area right there. Here's Makaopuhi, the earthquakes in that area right there. Here's the bend in the rift zone. So you can see that at least in this East Rift, there are some similarities happening as far as where the earthquakes are. Right? They're having less activity on the Upper East Rift itself, but more so on a Kīlauea in this era. And it just shows like of this triangle, that was the arm that was adjusting at that moment in time of that eruption. So moving on, there is an interesting graphic here that what we're doing is looking at Kilauea from the summit to the tip of the East Rift. And we're curious, where along this East Rift are these eruptions happening over the 60s? So actually a little bit before that. So let's come to the bottom here. This is 0. This is the left end. This is by the summit. And this is by Kapoho, 30 miles away over here. So you can see 54 eruption at the summit, 55 eruption in the lower East Rift. So what's important here is the length of the line here is showing you where along the rift zone is this eruption happening. So if it's very near this end, that's the summit. These numbers, by the way, are chemistry. We can ignore them. This is basically just saying how evolved the magma is. So the higher it is, the closer it is to summit magma, and the lower it is, the more evolved magma it is further from the summit. That's all that really matters here. So ignore that. But what you can see is that 54, 55 was a lower East Rift. 59 at Kīlauea, 1960 lower East Rift, Kapoho right there. And then 61, here's our lower East Rift boundary right there, more or less. 61 does the Middle East Rift and sneaks just across the lower East Rift boundary. Before in 62 we go back up rift, 63 up rift and then down rift. 64 is no eruption, 65 early, There it is, and 65 late in December is there. So you can see at this moment in time, they're seeing a progression of the fissures are going further and further uprift with every eruption. That would change later. But for now, they're basically seeing the rift zone appear to be getting clogged further and further down, and it's erupting further and further towards the summit every single time. Right, and what's going to follow this era is going to be 9 months of summit eruption as well, following this in 1967. So interesting to see how that actually maps out across that part of the rift zone. Let's scroll past all of this. And note here, let's see here. Just want to make sure I read just what I need to on here. So I think they're talking about earthquakes were increasing towards the end of 62, early 63. Well, let's just go to the description of the eruption here. So they note deflation at the summit that begins at 3 in the morning. Then they begin seeing tremor at Makaopuhi and shallow earthquakes, presumably from magma that has left the summit and is injecting into the East Rift. And here you can see what that looks like in a tiltmeter. When that happens, the summit deflates. So here's our eruption we're discussing right now, which is October 63, this one. So there's a big drop in summit signal, which is what you get when you have a rift eruption. The one prior to this in August, Li, had a much smaller drop, much smaller eruption. There were 3 previous intrusions that caused summit deflation, so earthquake swarms. This one was Southwest Rift, Upper East Rift pattern, not unlike what we just have seen recent months here. And then back to 62, there is that eruption also showing up on there. And while I'm looking at these graphics, we can look at this one, which is the timeline, hour 0 on October 4th, midnight, going all the way to October 9th here. And so from the bottom, eruptions, this is a volume of lava. So lava comes out from just before 6 a.m. on the 5th at Nepal first, and peaks early and wanes, and before it dies all the way off, we see it ramp up at Kīlauea. That's about 4 miles east. And then it dies down over the course of that next evening overnight. Then we see the last little pulse coming up just before noon on the 6th from the central area. So 3 different areas are erupting there. They note here observations by airplane with a little plus and on the ground with a little asterisk. So observation on the ground happened basically only there, and everything else is periodic overflights and snapshots of what's happening at any moment in time. The tilt at Kahuna, you see here it is dropping down. You see how that happens just slightly ahead of the eruption. I know my line wasn't straight, but still. Right? And then you see the earthquakes picking up at the same time, and tremor across the volcano as well. So, all right, so we come back to our description because there are some interesting details in here that we don't find any other way. So they noted the deflation at the summit. Magma is moving into the East Rift. At 5:25 a.m., an apparent air shock awakened most of the residents of the summit area. And following it, the harmonic tremor increased markedly. The eruption in the Nepal crater probably began at this time. So they actually hear something like a sound that seems like it wakens everyone up at the summit, right? That's pretty incredible. We can probably imagine what kind of weather there must have been to carry the sound, and how loud it must have been to project that distance from the Nepal crater. Has got to be 7 miles away, maybe? It's a ways away. So everyone's up at 5:25. The geologists run to the observatory. They drive to Makaopuhi crater, which is as far as they can drive. And from there, they note a billowing fume cloud and hear a faint roaring noise to the northeast, although vision was impaired by heavy low clouds and light rain. So how did they get more information? Well, a pilot in a crop duster aircraft flies over the crater, and despite low overcast, he sees lava fountains from a fissure that go across the floor of the crater. He flies back an hour and a half later and still sees the fountains there. By 7:35, the geologists at Makaopuhi are listening to the eruption and not seeing anything. They note that the sound decreases to faint booming. And by this point, instead of light rain, heavy rain clouds are coming in, to the point they cannot even see any fume. At approximately 7:30, a party of pig hunters on a Kalapana trail, about 2 miles south of Nepal, began to smell strong sulfur fumes, and they heard a roaring sound to the north. Shortly afterwards, they see scorched leaves and ash carried by the wind falling around them. So they abandoned the hunt and headed back up the trail, reaching Makaopuhi at 8:40, where the geologists then encounter them and likely get their report. At the same time, the observatory crew is hiking the Nepal Trail over to try to see the eruption. So back to our map over here, there is a trail that goes from Makaopuhi over to Nepal. So that's where they're walking over there. And they arrive at Nepal at just before 9 in the morning, and they observe the lava fountains that the pilot in the crop duster had actually seen. They can then note the fountains were 50 feet high, 100 feet off of the 1840 vents, and the whole crater floor is getting filled with lava. By that point, 70% of the crater floor covered by new lava, which appear to be at least 20 feet thick. They noted that the trail to lava trees on the northwest side of Nepal crater, so there had been some around there from the earlier eruptions in the 60s, was cut by a new fissure north of the junction. And when they see it, it had already been erupting a small pile of lava and putting out lots of gas. So there, you can see they're flying over again. They fly back over. They see the line of vents at Nepal. They also now note a line of vents 3 to 4 miles east-northeast of Nepal, fountaining 50 feet high. So what's happening is as they're trying to track this eruption, it's moving to the east still. So, all right, the vents in Nepal begin to drown in the lava over there, and maybe that's why the Nepal eruption perhaps wanes. But just before 2 p.m., there are new outbreaks of lava 3 to 6 miles east of Nepal. And here they note there are limitations. The exact pattern is incompletely known because of inaccessibility of the region, cloudy weather, and a featureless aspect of the landscape when viewed from the air. They see the fume is spreading at Glenwood, where I just mentioned Don Swanson going to look for a glow from Puʻu'ōʻō. They can see fume from there, and they note that it's in the direction of Kilauea crater. So that's where they know to go and look that far down the rift. So a flight makes it over Kilauea by 2 p.m. They see fountains 1/4 of a mile long and 150 feet high. They come back at 6 p.m., where the fountains still occasionally attain heights of 150 feet, but diminish intermittently to 50 to 75 feet. It's making 2 flows that move down a rift zone in the east-northeast direction. Much of the lava in the northern stream flows into a big crack. And because they'd come by and taken photographs of this area a few years prior, following a previous eruption, they know that there was no crack in October 61, and there was a giant crack swallowing all this lava by October 63. So it was likely that crack formed during this eruption buildup. They note that the flows reached 1.25 miles long from their vents, moving less than 1/4 mile per hour, but they were filling lots of cracks that they were coming across. And they note that the advancing flow fronts and transverse cracks perpendicular to the length of the flow We're all brightly incandescent in the darkness, along with hundreds of twinkling flares dotting much of the surface of the flows, caused by trees bursting into flame when surrounded by the thin lava flows. During most of the night, a bright red glow was visible from Pahoa, Kalapana, and Hilo, despite intermittent rain and cloudy weather. The glow decreases over that night, though it only lasts most of that first night, decreasing at 3 a.m. and gone by 4 a.m. By 6:30 a.m., they fly back over. Note all the vents are quiet. Some fissures are glowing red and shooting red-orange flames 10 to 15 feet into the air, but no lava. However, they do note that lava flows are still moving very slowly, 1.5 miles from their source. And that is the last thing they see. Besides all the cracks vigorously steaming and degassing and carried southwest by the trade winds. So that might seem like it's the end of that, but they actually fly back over 9:40 October 6th, and you see a new fountain of lava at 9:50 a.m., spattering feebly and ending finally on the 6th. So that was the sequence of eruption there. Let me pull up just our October 63 eruption here so you can see it and imagine what they're talking about, because it's hard to see it without having graphics, in my opinion. Right, so here's Nepal crater. Let's zoom it in. Right, there's the fissure that cuts off the lava tree trail and access to Nepal crater. Here's our 70% of Nepal crater filled, and the cracks that propagate to the east from there. Over here, there is that area over here that also had a last pat of lava. I'll come back to this in a minute. And over here by Kīlauea are the source events of this fissure, the flow going down on 2 branches all the way to there and to here, that 1.5 miles away. So that's the pattern described in the text there. But there's a little more than this that they actually share. And let me come back to the paper now. So, and come up to this map, further up. Is this the map? No, maybe I already got a different map in mind. Let's see if it's further down here. And well, I guess we'll see the pictures next. Okay, so here, following the eruption, looking northeast from Nepal crater, here is a line of fuming cracks through that very heavily vegetated rainforest of the East Rift Zone at the time. Pretty grainy, that one, but that's the best we have. We look at Nepal crater itself. Here is looking into Nepal, and they're noting these little bumps are lava trees, indicating that there was forest inside the crater before this eruption. So they note abundant tree molds came across this crater. They note that this entire crater floor is going to be recovered in March 65. Well, that'll be our next eruption to talk about. So Nepal is going to be covered over and over again. And this was really the last of the forest in Nepal at the time that got hit over and over again. So they do note that many of these flows are hot, pretty gassy and thin, which means that they flow through the forest pretty quickly and then drain away and leave lava trees. So many of these early eruptions in the 60s have lots of lava trees being formed because there's so many trees in the area still, and very short eruptions that essentially create flash floods through the area and then subside after the fact. So that's most of the 63 eruption. Let me scan through to see if there's anything else to highlight for you guys here, but without reading the entire paper, there's a lot more detail obviously here. Let's see here. All right, so here is what I wanted to highlight as far as buildup of earthquakes. Earthquake activity was high before and during eruption. Prior to the eruption, an abnormally high number of shallow earthquakes was recorded beneath the volcano, reaching more than 100 per day by mid-September of 63. So for at least those 2 weeks, maybe 3 weeks, you have more than 100 earthquakes per day, all the way through the time of the eruption. Right, so that was the kind of buildup as far as the earthquakes before we saw that decrease until at the summit. So that's the most important thing to highlight there. I'll just skip past the rest of this, and I believe that's really all we want to talk about in the 63 eruption for now. So we'll advance to March of 65. And let me once again come back to our map. That's October 63, and here is March of 65. A little bit further to the west, including Makaopuhi crater. So this one was actually a 10-day eruption. This is the longest one we've seen. All of our eruptions so far have been 1 to 2 days, less than a day to maybe just slightly over a day. So we have 10 days. We have the largest volume thus far, 15 million cubic meters of lava. And it's filling the pit in Makaopuhi crater. In the end, it leaves 83 meters of lava. That's about 275 feet of lava that filled the pit of Makaopuhi during this eruption. They note that there was inflation of the summit beforehand and deflation as the event began. They note that the inflation centers were moving around before the eruption happened. It was not simple. They actually note in this case, unlike the previous one, seismic activity was exceptionally low in the months preceding the eruption and during the eruption, actually, as well. So a little bit different there. And otherwise, it took more details about the lava itself, which I will not go into today. So here we are, eruption number 5 on the East Rift Zone. I will scroll down to the map here. And here, similarly, we have 3 zones of eruption. 1 near Kīlauea, 2 right in the middle, that's not too far off of where Puʻu'ōʻō now sits, and 3 that's closer to Nepal crater itself, right there. And so come back to those 3 areas of activity there, and as well as Makaopuhi crater, which is the main observation site over here to the left. Yeah, and so let me see here. Somewhere it says that because this eruption was actually accessible, it was the best observed eruption of this entire sequence, and a lot of good science was done because of this. So let me come down to what we want to highlight, which will come by all these graphs. We've seen these tilt graphs before. This I thought was interesting. We often look at our monitoring data and we look at the cross caldera distance in Kilauea. So this began in October 64 with Bob Decker measuring that cross caldera distance. And we don't have a graph of it, but he does note that between October 64 and March 65, that line expanded by 12 centimeters. Then it contracted 28 centimeters during eruption, and afterwards it expanded by 12 centimeters again following that. Right, so similar patterns is what we see today. And more of the graphs of how those earthquakes propagated there. And the interesting thing here is Makaopuhi crater, shown in this panel right here. This is extrusion rate, how much lava was coming out, how fast. A big burst at the start, a gap of quiet, a pause, a slow startup that ramps up and starts accelerating faster and faster and faster and faster, and then immediately stops, crashes out there. Here are earthquakes, both at Makaopuhi at the beginning and then as it resumes, coming up here, and tremor at the summit and Makaopuhi as well on there. I'm going to scroll past a whole bunch of math that they put in here in this paper. They're still trying to figure out how the tilt and volumes correspond to each other. So the first indication of a possible eruption was onset of shallow tremor, first at Makaopuhi and then elsewhere in Kilauea. Barely perceptible at 8 a.m. on the morning of March 5th. It increased rapidly, and by 9:30 reached a maximum for a few minutes. Scroll past some more of the math there. It's surmised that the eruption, also, okay, the summit begins tremor as well, similar time, but that corresponds to the summit deflation as well. So high tremor amplitude at the summit is matched by high deflation rates, and when it slows down, also low deflation at the summit. And one curious thing to note up here, let me come back to this graph up here, summit deflation here, this is north-south and east-west, starts off and actually levels off pretty quickly, right? If you note this 10-day eruption, there's lava coming out all the way over here with no deflation of the summit at all happening. So this is a really weird eruption in two different parts here that have two different characteristics because of that. So, all right, keep going down here. This is the summary of what was erupting and when. So Makaopuhi crater in the west pit, that begins the eruption on March 5th. It ends later that day, but resumes the next day and goes all the way to the end 10 days later, right there. Elsewhere, Makaopuhi, there's one strand that's just off on the wall of the crater that only lasts a couple hours. There's another strand that's further east of Nepal that lasts most of the first day. The strands that open up later in that first day don't last about a day over by Kīlauea crater over there, right? There is that renewed activity east of Nepal crater at center of number 3 that occurs March 9th to 10th. And then following March 10th, everything is back into Makaopuhi crater for the whole rest of the eruption. So Makaopuhi is the start and end of it, with a lot of stuff they couldn't see over to the east in between. So that's more or less it. They have volumes in here. I will not go through that. That's basically the summary there of what happened. They do note that once again, even though lava fills Nepal crater to the point where it was overflowing at a low point in the east wall, drain back into vents through the floor of the crater, remove most of the lava, except for leaving about a 7-meter, maybe 25-foot high escarpment at the east end of the crater. The amount of lava erupted to the surface is substantially greater than that was left on the ground because of the drain back. With a particularly striking example by Center 2. So we'll look at that when we see the picture of that coming up here as well. So some images here. This is vent number 2 in the middle of that center right there. This is what they called Puʻu'ōʻō right there, which I have not heard before. That is more or less underneath Puʻu'ōʻō today. I'm not sure exactly the location, but that's about the same more or less area right through there. So there it is right there. You can see the widest trees is where there have been cracks with steam killing off the trees in this area, all through here, all the way to Kananui-Yohamo is back there, which means the Nepal crater is right here in the foreground right there. So Puʻu'ōʻō, and a little bit of a flow that emerges from this thing and flows a short distance off to the east there. They note the filling of the lava lake. The crater, that west pit of Makaopuhi, so there was a crater inside of a larger crater here. This western crater was over 1,000 feet deep before lava starts pouring into it, and fills it up that 270 feet during its first eruption. This is a little bit reminiscent of what we saw at Halemaumau starting in 2020. Here's a view before that 65 eruption into Makaopuhi. So this right here is that west pit, the deep one, 1,000-foot deep right through here. And this is collapsed through an earlier lava lake that's filling the whole rest of the crater. And this is what they call that mezzanine on the east pit, that shallower east crater floor right through there. So pretty amazing. At the time, you probably could have seen this, the inside of this frozen lava lake from the side right there. It must have been amazing. This photograph's too grainy to see much through there. And now lava's buried this entire crater and has flowed across this area, so we don't see anything like this anymore. But it's fascinating to see the change of this area since then. They did note that there was a very small flow in the bottom of this pit crater that dates back to 1922, which was a previous time to the 60s that there was Middle East Rift adjustment, like we're discussing today. So the eruption begins on the upper wall of Makaopuhi crater, feeds lava down into the crater right there. Let's show you guys this in color. So this slightly different angle, but that's how that actually looked on the wall of the crater. Big fountains, big rivers of lava pouring down into the crater. They note how at first this fed a flow across the center of the crater right there that would then split and circle back along the far walls. This is similar to what you see like in a plunge pool under a waterfall, right? But after that initial filling, and once the lava gets a little bit deeper and has a little bit more volume there, it actually begins clockwise circulation for the rest of the eruption. So when you see this double-lobed circulation, that's indication that's an early eruption photograph right there. So the lake keeps evolving from there, right? So here's a different view, looking up at the upper wall, lava pouring in across there. And here is that clockwise circulation. You don't see that streak across the middle anymore. And you see there it is, pouring in and spinning red around the outside and cooler in the middle, like a little vortex right there in the middle. And at later stages, when lava stops coming out, then you see the lava lake actually forming a crust, and that crust overturns through crust refoundering and flashes red like we're seeing in this photograph here. All things we've seen in a Mauna lava lake as well. So it's a little bit of a visual detour there from our black and white paper. So there, by this point in time, lava is circulating clockwise. Vents to the left and the right of the center have died by this point of this photograph. Yeah, another image there. The crater is filling. Let me pull up the map back up here. This one right here, right? So they note that here's where the overlook is from the road, Chinook Craters Road. Yeah, turn around a little further. They note there's actually a pig hunting trail off the Napao Trail. Here's a Napao Trail that way. Off the Napao Trail is a pig hunting trail that goes down into the crater and all the way to the bottom of that west pit, actually. So the scientists see this and they start using the trail and they start going down there and collecting samples from the edge of the lava lake as often as they can. And this is why they had so much fun this eruption, because the lava was actually somewhere nearby. They could drive to it and go and take samples and observe the changes over time. And so there is a fissure line within the wall of the crater. This dotted area is everything that got filled in this particular eruption. There's a second strand of fissure up here in a wall with a flow that comes down just onto this mezzanine. It didn't last more than 2 hours right there. Right, that's the part of the eruption that was actually witnessed in real time at Makaopuhi crater. Everything else was once again from photographs and aerial reconnaissance and that kind of stuff. They note that when lava was going down the slope, it was 35 degrees steep, which gave them 20 to 40 miles an hour speeds of lava down that slope. So these are all important measurements that that the scientists are making for the first time a lot of times, measuring viscosity, measuring the depths, fountains, gas content, all that stuff. So let's come back down to the photographs over here. Okay, so that first pulse in Makaopuhi is a pulse, so it puts a lot of lava out and it starts ending, starts not putting out lava as much. So the lava output's reduced. We start forming a perched pond. In the lingo of the day, they call these pressure ridges on the edge of the perched pond there, right? And so they note that there's like a lower segment, like a moat, and the perched pond spilling over onto that as well occasionally. So similar to what we saw in 2020 and 2021. But then what happens is that the lava reactivates in Makaopuhi. So the rate increases again after that pause floods the crater, buries a perched pond. Some of those perched pond features become little islands that start, that are surrounded by lava within the crater here. And the lake keeps filling and filling and filling. And so from this series of photographs, here's one from after the eruption is over, where they actually see that the highest vent that occurred on that fissure wall. And when did the eruption actually stop? They say it stopped immediately when the lava reached the height of that vent and drowned it. Very similar to what we saw in our previous eruptions in 2021. And as soon as it gets drowned and stops erupting, it starts draining back. So you start losing lava from that point in time. And so this is pretty interesting. So yeah, so the cracks are filled with some of the mineralization afterwards. So you can see the surface of the lake down there. But what's interesting is how they actually got this filling rate. So if I scroll down, they actually have this graph they made here of how it actually filled from March 5th. Eruption ends on the 15th right here. But for 4 more days, they have draining of lava still. So here's the filling of the lava lake really fast at first. There's our gap. Then it starts off, actually starts slow, starts accelerating. This is weird because the crater is skinny at the bottom and fat on top, just like the ones we've been dealing with. So you expect the rate to actually be doing the opposite. You expect it to actually be doing this if the volume output stays constant, because you have to fill more area. So when you see it actually take the other way, this is really unusual. It's actually accelerating more and more and more and more and more, and then it just cuts off all of a sudden. So really interesting dynamics in that eruption right there. Right, and remember, not much earthquakes in advance as well. And so how they actually got this graph was by walking that pig trail down into the crater when the lava lake was still really low. They went to different blocks of talus, like big chunks of rock that fell off the edge that rolled down towards the edge of the crater. And they spray paint giant numbers on them and letters on them that they can then, from an overlook with the binoculars, be like, okay, lava's reached that block. And each of those blocks is a data point. So lava reached that block, and that's how they track this through binoculars and timing after having walked down a pig trail and spray painting the rocks. So pretty amazing technique. That when they were actually down there, they note how they actually had to. Let's see here if I can find a description of how they did that. They use like a hand level and a measuring tape like between the blocks to try to figure out how far each one was from the other one. And then they got to the highest one. They hung a rope down from that upper crater to measure how far below that rim it actually was. And that's how they tracked the filling of the crater at the time. So nothing too fancy. Just some innovation there, right? So that's the fascinating part of this March eruption. This is they're actually trying to note temperature. Like this is lava chemistry. Once again, I won't get into all of that. More lava chemistry through here. I think this might be all we're going to talk about for this March 65 eruption. Here, there's a lot of chemistry that I will not try to explain to you here. And yeah, that does 65 for us. So let's go back to Google Earth, right? And one interesting thing that I want to just rewind for a couple of seconds here, right? We talked about, so, all right, right here, this is Puʻu'ōʻō. And so October 63, there's that first outbreak from Puʻu'ōʻō area. And actually that earlier paper says how this flow was extremely hot and fluid, made lots of lava trees in this area. And interesting to note that because that area is the one that forms Kimo later on. And eventually we have Puʻu'ōʻō there sitting there today. So it seemed like it might have been a little bit of a weak spot in the rift zone, even back to the 60s, as we can see from the pattern here. So December 65 is going to be even further up rift and smaller footprint. And there it is. And so let's look at that one fairly quickly. Here, December 65, question paper 607. is where we are now. And this is by Dick Fisk and Bob Koyanagi. There weren't a whole lot of USGS staff then, so they were all doing a huge amount of stuff, and their names are all over everything. And so let's come down here to the abstract for this eruption. This one was only 1 million cubic yards, so a lot smaller. It only lasted 6 hours, and it happened on Christmas Eve of 1965. So it begins around Aloy and goes all the way to Kananui-o-Hamo. It fills a lava lake in Aloy crater and puts a pad of lava east of that crater that covers some forest. Later on, the lava withdraws back into the cracks and drains away, and very little lava is left on the surface after the fact. That, however, was a very small part of the entire crisis, which actually lasted more than a week following that, with thousands of earthquakes, cracking occurring west of that area into the Kauai fault zone all the way to the Kau Desert. And hundreds of ground cracks, and that area dropped down about 6 feet. So big changes happening there. Here is a map of this area showing what area was actually cracked up. So our eruption site, as you'll know, is going to be in here at the east end of this. This is just a very tip of it. You can see cracking occurs all the way down to near Puʻu'ōʻō, which we've heard earlier this year in regards to the Southwest Rift eruption we had in June, was right around in here. So there's that triangle. We keep discussing the Kauai triangle with a Southwest Rift Zone, the Upper East Rift Zone, and the Kauai faults themselves. That this whole area south of the caldera is like an extra mobile and area of storage, of injection of lava over and over again. So fascinating area. And you can see here that in this case, after years of eruptions going further down the rift over and over and over, we actually were all the way up to here. We've now actually back propagated, or actually having effects into the Kauai to the west. And just to recap, following this eruption, we'll have no activity for about 1.5 years until we see the summit eruption in Halemamau, 67, 68. Okay, I see a ticker on there. That means I have limited time. So let me get to a point here. All right, so December was actually a lot shorter and smaller than 65. You can see here in a tilt record. And let's see if I can recount some of this chronology. So earthquakes began Christmas Eve at 7:30 p.m. 8:13, a bigger one, actually puts everyone on notice. Scientists leave HVO at 9:25 when eruption appears imminent, and they see orange glow over the Upper East Rift at 9:30 p.m. They rush towards Aloy crater, but 500 feet west of the crater, they have to stop because the cracks are crossing the road with gas coming out of them. For the next 2 hours, the clouds prevent observers from proceeding to the point where they can see the eruption, but they see the glow and note the roar and changes in glow and all of that stuff going on through that eruption. They note there's a spray of lava, Pele's hairs, and a climax at 10 p.m. when a small amount of lava sprays from one of the newly opened cracks just west of the crater and showered clots of glowing ejecta over a small area only 70 feet from where the observation party had temporarily grouped. So a little bit of a close call there. They make their way after some waning to see more of the eruption. When they get to the overlook, they see the eruption of the crater was nearly over. They see the little bits of lava still being shot out of there, plastering the walls 40 feet above the floor, but having since drained back down into the cracks. They do note glow in the sky to the east, so they know that there is lava in a forest east of there on a flank of Kananui-o-Hamo. So they see that there's mist and rain comes into the area. They have a hard time figuring out where things are exactly. And so a little bit of gray area there, but they pick out the information best as they can. They note more glow appearing 1.5 miles east of Hawaii crater the following morning, and then nearly dark by 4 o'clock, having it be the end of that. So that final piece of glow is expected to have been not a renewed lava fountain, but actually a crustal overturning of the lava lake that made the sky bright once again. So before sunrise on Christmas Day, the eruption had actually ended. So there's lots of information. Also, earthquake spiking, tilt dropping down, ground cracking is the most interesting thing here, because eruption actually occurs early on. Ground cracking continues for 4 days further than this. Here is that location of where the cracks were within Eloi crater. Further east, there's that pad of lava, number 1, and then number 2 over here with 2 different fissure segments, right, all the way to the flank of Kananui Ohamo up here in the wall. Here are some images of what this actually looked like. This is the Hilinapali Road, right, and that Kauai fault zone crossing the road opens up this gigantic crack nearby there. And another one widened to 10 feet there. They actually talk about how the caretaker of the Idaho Ranch, let's see if I can find that somewhere, right here. Caretaker of the Idaho Ranch witnessed the opening of that crack. He was alarmed, attempted to evacuate, approached the pali from the south, paused to look at the glow from Eloi to the east, only 1 mile away. And an earthquake jolts the area while he's standing there. Opens a crack 3 feet wide and at least 20 feet deep, just north, a few feet north of where he's standing. Now he can no longer drive his automobile across the crack, and he's forced to speed back to the ranch and spend the night lonely and terrified. So they also saw another crack open up on another part, not the Idaho Road, but the Hilinapali Road here. They noted that on the 25th at 8:15 in the morning, the crack was barely 2 feet wide. With careful maneuvering, it would have been impassable in a 4-wheel drive vehicle. But at 8:40, the area was wrenched by an earthquake so violent that it nearly toppled a vehicle parked nearby, and the crack abruptly opened to about 5 feet. This and others continued to widen as a swarm of earthquakes continued the following days there. So lots of cracks, lots of different times opening up. They haven't untangled it. They just know that lots of cracks opened up across that giant area with a map that we showed you guys. And that's as detailed as it could get. There was collapse subsidence at the summit, but it was very weird. Here's Halemaumau in the main caldera. You have one deflationary center under the north rim here, closer to Uikahuna. You actually look like you have like an injection of a dike right across the center of the caldera. And you have this big deflationary center under the Kauai in that triangle to the south. So really weird stuff happening here. And you can see why from this, why all the cracking occurs further to the south. And there is that crack. Here's like the zero line. So everything on this side and side of here all moved down. Everything oceanward from there moved up. And the eruption was only over here. So a couple interesting things with the photographs. Here is a view of the fissure lines as they were, with the fume going up the crater wall. An Eloi crater, lava had come all the way up to here, but drained back down the cracks. Actually covered some of the earlier features, like the perch pond from a previous eruption was covered over here. So interesting on that fume there. Here's further east by Kananui Ohamo. Another crack. Lava is frozen, draining back into the crack. Drain back features here. There was actually some spatter built up on a spatter rampart of 1840 right next to this as well. And this is an interesting study about lava trees. So when you look at a lava tree, you can see which way the lava came around it and where it left a tail behind, which way it was flowing. So early on, the flow was moving to the northeast, maybe sweeping across this way. So all the lava trees line up to that. But after the main post comes out, lava is draining back into the cracks. Now they see all the lava trees aligning with the draining back into the cracks. And this happened when lava was at different depths. So really fascinating. This is what they call a spiral tree mold. So at the top of the tree mold, lava is dragged across this way. So flow is going this way, left to right. But there's a crack right here. So as lava is dropping down and down and receding, when lava is down in this area, it's actually flowing this way. And when it's down to here, it's flowing this way. So you actually have the spiral directions of flow preserved on this lava tree. Really cool stuff. It shows new flows, picking up old blocks in the area. Interesting flow features there. And that's really most of what we have to share about this December 65 eruption. And so the important thing being that it was not only an eruption, but the eruption was only a small piece of the overall big adjustment of the volcano that went all the way to the Kīlauea that really concludes this first half of the decade of the 60s before the shift back to the summit and more of this adjustments. I think I had better leave it at that and pass it to you, Dane. I believe I'm going to have a power issue here shortly.
Yep, I think we are at that point. We do not have any questions in the chat. So, yeah, I know we're coming up on 2 hours here, and our ASL team has to go here shortly. So, should probably get into our wrap-up.
Sounds good. Well, that's the 60s, and you can see how there are some parallels to what's happening today. And we don't know what will happen today. But these are all things that are possible. This kind of character of activity, adjustment, injection, intrusion, small eruptions, all that's on the table as possibilities. So we'll finish up the sequence next week, perhaps. And yeah, what else have we got until then? We'll keep an eye on a volcano as usual. If we have something happen between now and then, we'll hop back in as we do. But otherwise, we'll return to conclude this story and update you guys on what's happening with Volcano next week, Thursday at 5 p.m. Hawaiian time, our regular broadcast time. Anything else, Dane?
Not for me. I think that sums it up. We'll be Queen Lily Kalani Festival this Saturday, so stop by and say hi.
All right. Well, from HVERI, a nonprofit, we have Dane DuPont. I'm Philip Ong. Mahalo to our ASL team, Carrie and Dano Kaufman. Appreciate you guys as always. Appreciate all your effort with all the names I've pulled out of the hat today and all the reading I did. And really your commitment to keeping our all of our communities informed. So mahalo to you guys. All right. So let's roll our outro, and until next week, from HVERI, Dane, Philip, this guy's ASL team. Aloha, everyone.